have 6.022 times 10 to the 24th moles of each of these two substances. So to find the limiting and the excess reactants, what we're going to do is divide the number of moles of each substance by the coefficients. So for oxygen gas, we find that we get 1.204 times 10 to the 24th, and for the ammonia we get 1.5 times 10 to the 24th. So we use these numbers to find out which reactant is the limiting reactant. Since oxygen is the smaller number, that means that's going to be the limiting reactant. This makes sense because for every 5 moles of oxygen, or for every 4 moles of ammonia that reacts, 5 moles of oxygen are used up. So that means that the oxygen is going to go away a lot faster than the ammonia. So using this information, we take the number of moles of the limiting reactant, and that's how many moles are going to be used up. So this number that we divided by 5, we're now going to multiply by 4 to find out how many moles of the ammonia are used up. And for that we have 4.82 times 10 to the 24th. So when we do that math, we get an excess of 1.204 times 10 to the 24 moles. So then, completing our BCA table, so we know that we used up all of this, and we end with 0 moles. So then, completing our BCA table, we know that these coefficients are the same, so this number is going to be the same.
And we're going to do 2 times 10 to the 2 moles on 165
and then we also, dividing this number by 4, multiplying by 6, we get 7.23 times 10 to the 24th moles. So the question asks us to determine how many molecules there are left in the container after the reaction has gone to completion. So to do this, we are going to take the moles of all of the compounds that are left and divide them by Avogadro's number, and then add them together, and that'll give us how many molecules. So to start, we'll start with the ammonia over here. So 1.204 divided by we got 1.204 times 10 to the 24th divided by 6.022 times 10 to the 23rd gives us a rounded value of 2 molecules of the ammonia. And for this one, we're going to do 4.8 times 10 to the 24th divided by Avogadro's number. Gives us a rounded value of 8 molecules.
I'm so sorry.
And then for the water molecules, we're again going to do 7.23 times 10 to the 24th divided by Avogadro's number. Gives us 12 molecules of water. So in